Today I want to actually talk to you about a couple of new advancements in terms of technology itself, not necessarily a product specific, but there's some things that are very nice to actually showcase and demonstrate here. Before I get started, I'd like to ask, just very briefly, I like to get some of this stuff being interactive, but I have a lot of stuff to show you, not just to talk to you about it, to show you, which I want to get to it pretty fast, but I want to put a meaning to us to why that's important. So let me ask very quickly, how many of you, by raising your hands, have heard of a product or company called Cohesity? Raise your hands. Good number, just about everybody. So here's a couple of things before I get into some of the stuff you're going to see. So Cohesity is a company that delivers a platform for data management solutions and capabilities for virtualized physical and application infrastructures. For the most part, so far, I think most people, most organizations recognize it as being a data protection product or solution, and it's not. It's one of the many things that it does as it pertains to dealing and managing information and data in the enterprise. But you'll see here that what I'm going to show you is that I don't want to confuse you and I don't want to give you too much, but I'm going to show you an example of leveraging the new technology and capabilities for performing incredibly great data protections, but applying it into a different solution, to a different place, right? Which is one of the things that I do here. So one of the things that we do, particularly when it comes to infrastructures, is that there has to be a reason as to why we're using the technology that we're using. It's not just because we want to tinker and play around with new software all the time, right? So when you look at some of the items that, in terms of the problems that are trying to be addressed and fixed with this particular solution product from this particular company, it's addressing business issues, business problems that pertain to you specifically, and they typically pertain to some of these here, right? They're not all of them because there's a lot more, but when you look at the way in which the management of information and data in the enterprise is very complex. Why? Because it's composed of multiple point solutions, multiple products, multiple things that are so far actually outdated in terms of technology and capabilities with reference to architecture. When you look at the times to access information, the time to protect information, now we have this sort of evolution in this new era of digital transformation, as you've probably heard so much about, specifically from VMware. But at the same time, is the realization that IoT and all these different devices are generating information and data that we cannot process fast enough and recover and protect fast enough. So the generation of information has gone exponentially higher than it was in the past 10 to 20 years. So there's a lot of challenges we want to look at there, overcoming some of the shortcomings in times. Even though things get better, the economics on what we have to do get worse, because the more you want to do, the less money you tend to want to spend, particularly in those enterprises when it comes to acquiring new solutions and dealing with a lot of those requirements that are there. Understand that the requirements for expenses do not only come from purchasing new software, new hardware, it comes from operations, right? So there's a CapEx and OpEx in both. So obviously being able to deliver something that simplifies the requirement of more stringent sort of operations has a lot of meaning to the enterprise. Also not wanting or having to replace hardware from already sunk costs and investments that you've already made, you want to be able to leverage that if you can, if you have to, but not essentially do forklift upgrades and things of that nature when you run out of capacity or run a particular service or something like that. For the most part, how many of you are using cloud anything right now? How many of you are using Azure, Google, anything? Raise your hand, Azure or AWS. Okay, perfect. So here's the reality. So at my time at VMware, I was one of the first sort of architects, when the time I spent there when I was in the field, where we're trying to bring this whole notion of cloud, and the cloud sort of became, and we started that with the product that probably you guys know very well now, which is called vCloud Director, which is now it's repurposed to service providers. It was very challenging to do that. Cloud was more of a myth. Cloud was more of a people consider it as a place, but as it evolved, you have to now begin to understand that cloud is not really a place. It's more of an operation or a consumption model that can be consumed anywhere. Whether you do it today or not, whether you actually know it or not, you're probably most likely already utilizing cloud services that you're not aware of. You just don't have the direct control of it. But the cloud is real. So what that means is that when it comes to applications and solutions being developed, they have to be specifically developed to natively fit into this sort of cloud model and cloud consumption. For the most part, technologies that were developed in the past 10, 20 years are not able to do that because it just wasn't there. The requirements, the business requirements, what drives that was not something that was really available there. So it makes it very challenging to achieve those sort of cloud integrations with bolt-on solutions, which again, complex and introduce more complexity into your environments. Now, to give you a pretty good view on what happens and what we mean by the complexity and the risks that are at hand in terms of dealing with enterprise environments, in terms of dealing and managing your information. This is a sort of like a narrow view of what I'm going to probably just kind of cover very quickly today is the data protection space. So if you look at this logical diagram, you'll see that there are many components when it comes to a specific infrastructure to manage and deal with data protection and data management cases, which the data management domain is a very vast and huge domain. There's a lot of categories in there, but particularly here we're looking at data protection. So if you look at what's going on here, there's obviously the need for media servers, target storage, which deliver space efficiency features and services, which are also outdated and not as efficient as they should be today. There's tape libraries, there's a cloud gateway. There are other use cases that you probably support within the infrastructure which require a different life cycle, different hardware, different things to provide access to test and dev, analytics, and file and object services, which not every system does. All of that means a risk in your infrastructure. As many touches as you have, and I'm sorry to say, but I've been saying it for over 2 years now, we as humans are at risk to infrastructure management. The more touches we have, the more hops we have to take, the more complex the infrastructure becomes, the more at risk the business becomes, because we have to do that many things in so many times, regardless of how fine-tuned we have it. If someone does it in code, there's a comma somewhere, something always goes wrong, which has been proven. So this is very complex and very expensive, and the point is to overcome this sort of scenarios to deliver better value, better agility, more security, and keep information more secure, more effectively utilized. So what Cohesity does is it delivers a platform, a software platform, that introduces the ability to use different types of hardware, whether it be software or virtual hardware-based or even hardware-based, which introduce space efficiency capabilities that are much more advanced than what's been available for the past 10 or 20 years. So we also eliminate the complexity in the data center because it's designed specifically to work directly with cloud from out of the box. There's nothing specific, there's no bolt-on gateways. So we basically eliminate the cost, the risks, and the management overhead that exists there. From a data management perspective, from a data protection, we eliminate the need to have media servers, multimedia servers, and all these different things because as part of the platform itself, there's a suite of applications that run and could be potentially used for data protection if you want to. Now, the thing is that we're not in the sense of our way or the highway, where if you use, for example, other data protection solutions like Veeam, you can still leverage and use Veeam as your data protection solution, but then use our data platform to deliver all the other capabilities that you'll see here in a minute, right? So it's a very sort of collaborative sort of innovation here where it allows you to use your existing investments without having to throw them away. So we eliminate the need to have individual hardware for test and dev, for example, perform analytics, and even potentially file and object services. I won't get into too much detail specifically on that, but I'll be here most of the day. We can talk about it. But for the sake of the demonstration and the presentation here, understand that Cohesity is a lot more than just one-point solution, right? And one of the things that we do incredibly great is the file service capabilities that we have and own, which are very unique. And because of that, some of the things that I'll show you here today is what are made possible. So when you look at this sort of diagram now, which is simplified, it makes a lot of sense from a risk perspective, from a simplicity perspective, from being able to reduce risks in the infrastructure management, specifically when it comes to data, right? You guys are now facing things, compliance that are coming with GDPR and all these things where information is very sensitive on how it's going to be managed. Why have multiple distributed systems storing files, data, and information to then bring them onto one centralized system where it's protected, backed up, recover? Why not just have one platform, scalable, right, with a distributed architecture that can actually let you centralize, provide better management, better consumption, better processing of the information that you store and hold, right? So these are the things that are kind of becoming very relevant here. The one thing that you'll see from a lot of folks in the industry now, it's become the modern thing, and I think everyone claims this, the single pane of glass. I happen to gone through several iterations of the single pane of glass story, and I can tell you this. While now the single pane of glass makes a lot of sense and introduces a lot of value for software, specifically for software vendors, to you as a consumer, a single pane of glass is yet again another single pane of glass, which really doesn't cover the problem that we're trying to address, because everyone has a single pane of glass, and guess what? You're going to end up with the same amount of interface that you have to do every day to manage what you have to do every other day. So that becomes a challenging problem. But essentially, being able to look at the information very quickly into their own UI, it's great. But my real approach and concept for single pane of glass is having access to a standard set of APIs that I can put into my consumption model, my portal, the way I consume and manage the infrastructure, which becomes essentially way more efficient and effective. Some of the things that delivers is obviously simplifying, centralizing your operations, mitigating risks. That is the point of everything, folks. This is the point of what we do things and what we do it. It's not just about bells and whistles, clicks and no clicks. It's about eliminating risks from anything possible within the infrastructure, because now in the enterprise, more than ever, data is sort of like the new currency. It's the new oil, right? And it's very important, so we have to keep it safe and guarded just like it is. And simplifying the infrastructures will do that a lot. So some of the things that Cohesity does, you can take a brief look at what it does in terms from a platform perspective. If you think enterprise capabilities, space efficiency features, security, encryption, software defined, you name it. All of those things are there, right? So we cover a lot of components and a lot of pieces and flexibilities in terms of challenges in the enterprise from a platform perspective. At the bottom, we also solve another problem. We deliver a converged data protection and recovery solution, which is second to none. And you'll see this, and I will prove it to you instead of just kind of blobbing on and showing you slides. But there's some actual problems that are needed to be fixed and solved within the data protection space, which Cohesity does a very well job doing that, adhering to policy-driven capabilities and frameworks, as well as also exposing APIs so that you can use this from any sort of interface that you may be already using or may have adopted or consumed as your infrastructure management component. How many of you use VMware? I hope everybody, right? I did, I do, I still do very much. So these are all the points of native integrations directly without having to do anything whatsoever that Cohesity adds to VMware infrastructures beyond what I'm going to show you today. So when you look at endpoints, interactions, vCenter, ESXi directly, and I'll show you some really cool things in a minute. From a management and protection perspective, you know, we as vSphere admin tend to provide management and administration of the infrastructure, sometimes based on folders, right? We use VM folders and put all the type of databases, VMs, and provide accessibility that way. We protect the infrastructure in the same way. In terms of business critical applications, there are native integrations and drivers and agents that actually work with SQL, Oracle, Exchange, and some really great integration with RMAN databases. Some of the things that actually, while running on vSphere, becomes very challenging because of the size of some of these databases are immense. From a file service perspective, how many of you used vCenter, heard of vCenter, or thinking of working with vCenter? My greatest thing ever, right? That was my baby at VMware. I was there for, that was the thing I drove out harder than anything else. One of the things that vCenter doesn't have today, yet, still, in the works, is a file system, right? File services capabilities within the platform itself. So one of the things that Cohesity can actually introduce to vCenter, as you'll see here in a couple of minutes, is the fact that you can provide the ability for vCenter to serve as an NFS mount point, as an SMB mount point, but also as an S3 target, right? So you can deliver all these object-based and file service capabilities natively to vSphere and to vCenter, working with some of these capabilities here. One of the things that are actually very important in terms of integration, so if you guys use, and let me ask another question here, how many of you use vRealize Automation or VRO for your environments, right? One, perfect. You guys will evolve and adopt that better, trust me. So we actually have integrations directly with those tools and products where if you consume an infrastructure through a service catalog, that whole point that I told you before about, look, I don't want to have to show you my interface, jump on my interface to do something. You can actually do it from your own consumption model and your catalogs by integrating through the APIs and some of the workflows that we have in place, and you'll see them here. REST APIs are some of the most important things to have to enable that sort of single pane of glass capability. In terms of vRealize orchestration, these are all of the functions that are available today natively that can be connected to vSphere so that you can automate the process and do that. I'm one to be very operationally focused. I'm all about efficiency and mitigating risk, meaning touching, the less touches, the better. But I'm also against introducing plugins that are not really usable, that you just basically bloat your environment, expose you to more risks, and adds more work to you when it comes to patching and maintenance. I'm all about being against that. So how can I deliver something that presents an example of what we can do in terms of integrating natively with the infrastructure that you so love and manage, which is VMware, by showing you how some other stuff works. So here's a very quick 2-minute demonstration of an example of how we integrate with some of the things that vSphere related. And this particular is obviously running on virtual SAN. And what I'm going to show you here is instead of going to my UI to perform a function for data-driven, anything within the platform that we support today, I can do it directly from the vSphere web client without having to even install plugins, right? Which is another problem within itself. There are limits to that. This is the Cohesity UI. I'm showing you protection jobs. In this one particular protection job, which I'm going to use to add a workload and application directly from my vSphere management environment, I'm showing you there's only 2 virtual machines in that particular job there, right? Typically, someone has to do that as a secondary task or function, do the process, do that, and go through that. Why do that? Doing so exposes you to risk because we can forget to do that and then actually can cause a problem. We now have the ability so that instead of doing that as a secondary function, I can right-click onto the VM and select any one of these workflows that are particularly added, which will automatically interact live, dynamically, with the backend of the infrastructure that is protecting or providing data services for that environment. Here you simply provide the information that you need for the endpoints. In this particular case, it's just using one particular cluster, which could be many. But I didn't have to use a plugin that was specifically designed, built by me, with requirements by me or my company or my software, right? Which again introduces more risk and more challenges to vCenter itself. vCenter even has a limit in terms of how many plugins you can actually connect. There's some challenges there. So you want to avoid doing that. You can select everything you want directly from the interface that you control. This is what you're used to. Less time in terms of learning, finding things around. But this delivers a really true value in terms of what you can do in terms of integration. That speaks volumes to being able to restore, recover, move information, clone, copy, test, dev, whatever you want to do that we provide. We actually have a very, really good way of doing that. And this sort of shows you and validates that I'm going to go back to the job itself. No one had to touch it as long as you have the right permissions. You go back to that particular job, and you'll see that one more virtual machine is apparent in the number of options that are there, right? So very quickly that happens. There was no plugin installation. That was just simply leveraging VRO, vSphere Web Client, and what we have in place. That's something that speaks volumes when it comes to changes in capabilities. Now, one of the things that we have in terms of cloud integration, and so obviously there's this, what makes up this distributed globally data fabric that we have in place is that, as I said before, the platform itself, every feature, every product, every component builds up on one another. And they're all readily accessible for the cloud, for any cloud. It's not just the ones that we see here today, which are the dominant forces in the market in the industry today, Azure, AWS, Google, you name it. But also anything that has a standard sort of S3 level of API can actually be leveraged directly from here to consume, deliver services that are storage related, data mobility, and many things that are part of some of the products and features that are part of the platform, right? All of these capabilities are part of the platform. They're not licensed separately. They're not added on as a bolt-on solution. They're just part of the actual platform itself. And when it comes to the storage level capabilities that are available and presented to the cloud, we have things that are called Cloud Archive, obviously archiving purposes, Cloud Tier, extending your storage between local and actually a cloud service. Cloud Replicate allows you to replicate and have this sort of distributed data fabric across the world if you want to, and you'll see that. In Cloud Retrieve, which allows you to actually look at metadata from different places and locations, pull it if you want to, and also download information that you may want to run locally. This is what enables this capability that is a much needed requirement in the world today. So when it comes to having a solution that can extend in many flavors, whether it is implemented in a virtual instance, in a cloud instance, or even a physical instance, it's exactly the same software. It's exactly the same platform, delivering the same capabilities, allowing you to do things very effectively around anywhere you need it, based on data mobility, compliance facts, or many things that you may want. This is a sort of layout that is available today. This is not a future thing. This is something you can do actually today with release software and products that we have available. Delivers, asynchronous replication across many different targets, supports many to one, one to many, and utilizing some of the capabilities that are actually native to the platform itself. This enables the sort of globally dispersed data fabric that is much needed because you can not only consume a storage type of architecture that's meant for the enterprise, but also it's a mix of that on what the capabilities also are available for cloud, which for many years at VMware, we wrestled with having two kind of how do we bring them together, and essentially one wasn't good enough for the other, so now this is a way to actually bring the best of both worlds together. How many of you know about VMware Cloud Foundation? Raise your hands. What? Well, gut check. VMware Cloud Foundation is the future of in which the VMware is going to deliver the software-defined data center. It's going to be in a converged engineered platform that you will consume. It's essentially composed of most of the components that VMware delivers, which you buy and install and deploy separately yourself. VMware Cloud Foundation, it is a converged engineered solution that automatically deploys, configures, and maintains a life cycle of the entire software-defined data center regarding to scaling, expanding, availability, all those things that are done within this particular model, right? Simplifying, again, everything that we do in the enterprise to make things a lot better. Now, one of the things that we at VMware struggled for many, many years, and I was there for 11 plus years. So in the time I was there, trust me, we looked into how do we provide a solution that can actually help us protect, recover the infrastructure stack, all of our components and pieces effectively in a time that's suitable for a cloud environment for the modern world. And we never really got to that point to deliver something that covered everything in the way that we needed to, which exposed a lot of problems and gaps in terms of what the technology could do in terms of adoption itself. For VMware Cloud Foundation, that's a huge thing, because now you're talking about getting infrastructure that are deploy, manage, and gather in a way that it's more simplified, lifecycle managed, and all that, which is challenging when you don't have a way to protect it and bring it all back immediately, right? So that presents a really big challenge. So some of the things that obviously I was able to do, being the fact that I have so much VMware knowledge from previous experience and all those things, I was able to leverage some of the technology that Cohesity has and present it in a way and utilize it in a way that is not in a conventional form, which it could be, but it wasn't really meant that way. What makes this possible is the use of some of the unique technology that Cohesity has in terms of snapshots. So if you guys are familiar with the way VMware snapshots work, you take a look at the example on top, and that is a serially based sort of process that when you want to get to a specific point in time, things have to be committed and merged, and there's capacity, data, and things. That process is a very heavy process, which is, something why VMFS today faces some of the challenges that it does. Snapshots in vSphere and VMware are not very good in the sense of to keep them as a sort of protection policy, because they're just meant to do a specific use for a short time to avoid that. In Cohesity, we have a different type of architecture where we have a design that is based on a B-tree type of architecture, where it introduces a lot of capabilities and changes where now, instead of having to process every single snap that may be around, we basically put marks in metadata that actually lets us do this more effectively. If I ever want to return or get back to a specific point in time, I can achieve that very quickly by even going to this particular route, which is a new design in terms of implementation. That is a new snapshot, modern sort of technology and capability that Cohesity owns. And it's why you'll see some of the things that I'm going to show you here today. When it comes to availability and recoverability, these are two types of architecture aspects that can be entertained in different forms. So there's availability where, from a availability perspective, the VMware Cloud Foundation gives you availability out of the box. vSAN is the storage foundation that runs on there, which means that your applications, depending on what they are, may have, failure to tolerate equals X, right? The high level of availability, in case something fails, you're protected, you're there. But every availability solution has a limit. The limit here could be financial, could be cost, because if there's no cost constraints, you can have availability and keep going, right? Whatever you need, whatever it's needed, as much as you need to. It becomes very, very expensive, but also it serves a different purpose. Now, when you look at some of the things I'm going to show you here very quickly, in terms of recoverability, there's a point in time where availability is no longer suitable for an environment where, depending on the failure. For example, for those of you that are familiar with vSAN and some of the things that are available, this particular architecture has a fault domain which is limited in terms of the number of failures that it can tolerate. Right? Availability will work as long as you have systems to recover from. In vSAN, if you suffer a failure of 3 disks, 3 nodes, 3 racks, depending on how that is, you are not coming back from the availability solution that is provided in that place. You now have to go from availability to recoverability. And in that case, that's what that fits in. Right? So recoverability, in this particular case, comes from instantiating virtual machines, applications that are being completely blown away, gone. No copies, no replication, nothing. In faster times that potentially some of these recoverability solutions may be able to do it, or even in the case availability. And I'm going to showcase that to you here. My point here is this. Availability plus recoverability could be the new thing to introduce in a data center, because now you have less expensive ways to deliver the uptime and the recoverability you may want in an infrastructure, depending on whether or not you may want to use some of the features that are provided there. Now, this is not meant to replace availability. If you have SRM, Zerto, anything that has synchronous replication, that's what you need to use for your application. That's maintained. That's actually very useful. But with Cohesity, you have another option of the solution. So let me kind of go briefly through this here, because I want to show you a demo before I kind of run out of time. So how many of you are familiar with distributed architectures and consistency models? Raise your hands. You went to school, computer science. This is just awesome, right? So there's these concepts of resiliency that are applied into architecture, specifically distributed architectures when it comes to storage specifically, because it has to do with data resiliency and availability in those particular models. Distributed architectures are not, I don't want to say they're new, but they're obviously now starting to be used more often than before and for different purposes. So this becomes very important. In terms of availability and recoverability, there could be a single point of failure if solutions are not thinking about what it means to have the right level of consistency models implemented as part of your architectures. This is something that you can fix with a patch. It's an architecture problem that takes a lot more to fix than just a simple patch. So let me explain this to you. A cohesity cluster is deployed into 4 nodes. Typically, it could be 3 or 4. But in a distributed model, you want to do things where you write in, you perform multiple writes, you acknowledge in a synchronous way, so that data is resilient and available in the event of a failure, even on that platform, right? In this particular example, there are 2 consistency models that I'll speak of: eventual consistency and strict or strong consistency. The eventual consistency is a form where when the client writes, data is acknowledged in one particular node, right? And eventually, after some time, whether it be milliseconds, minutes, hours, days, whatever, that eventually gets distributed throughout the system. What that basically does is that it presents a window of time where if you access data from any one of those other nodes, it may not be up to date. But also, if there's a failure of one particular node where the data was acknowledged, you lose data, you lose information because it won't be there again. It's not distributed across the systems, right? That takes time. So there's ways to recover that, but there's challenges and risks that you are exposed to. Move on to the different model, which is in this case, come on, work. Don't fail me now. Come on, there you go. So systems eventually return latest writes, and there's potential data loss. Strict consistency is a model where the writes are distributed. So they're not acknowledged until every node within the cluster is actually received and, and we acknowledge it. And then we would send that back to the actual client, and then we say, okay, that was acknowledged. So that's a lot of terminology in terms of what it means in a computer science, a very low-level engineering aspect of this, just kind of to be brief. Now, what does that mean in the vSphere to you as a vSphere admin in the vSphere infrastructure? And you'll see exactly why this is important when I show you the demonstration after this. So if I have 2 systems, and I'm speaking specifically on mine, here's a VMware Cloud Foundation vSphere infrastructure running on vSAN. From a storage perspective, that's my primary storage. If I'm running a virtual machine, the machine dies. What happens is from my solution, I can instantiate a mount point that's presented in that eventual consistency model. And now what happens is that because from that one particular node, the VM can actually come up immediately. This is why you start hearing this term that says instant recovery and all these capabilities that actually become available now in terms of recoverability of information. There's a mount point that's automatically mounted into vSphere. Because of that, the VM can actually come right back within minutes or seconds, as long as I can power on because it's running here, right? But the compute is coming from vSphere. Now, in that process, all the I/O from read and writes are going to happen to this particular node on this system, right? What it means is that everything that's being processed is going to be stored here. Automatically, as a form of another task, the system will eventually start generating new data and storing it here. And eventually, the process is to move that actual virtual machine to a primary storage solution that it was running on, right? Whichever one array you may want to be using. Now, there is some magic, as you could say, some of the snapshot stuff that I showed you, which makes this recoverability process very quick, very fast, and very useful in a very quick manner. But when it comes to moving data from one storage point to another, there's no magic there. It's just physics and endpoint capacity and all those kind of things, which make it difficult to do that. If you lose a node, that's actually where you present that mount point from, you may have the ability to lose a VM, you lose any information that might be there, any new information that was collected, but also introduces problems to the infrastructure. The way Cohesity uses this implementation is by doing strict consistency, which means anything that happens within the infrastructure in that same scenario will not cause a failure to the infrastructure, because if one of the nodes within the cluster fails, the way which we abstract that presentation, any other node within the cluster can actually be used to provide the solutions that we're doing, right? So keep that in mind, because as you sort of get into that particular point, let me show you a demonstration of something that I brought up VMworld, which is fairly new. I mean, I typically ask the question, but I'm running really out of time. And I would say, how many of you have ever seen the recovery of a data center in under 20 minutes? Very few people ever raise their hands. If anyone will do it, I'll ask the question, how much did that cost? Millions of dollars, right? So I'm going to show you something that is not typically done even in exercises, and this was done in collaboration with VMware on campus and doing between 2 data centers. So what I'm going to show you here is the ability to recover and I'm going to walk you through this. I'm going to be kind of fast. This is VMware Cloud Foundation has every component that you have in VMware in the stack. vRealize operations, Log Insight, you name it. All those products, all those components, vCenter, PSCs, they're all deployed automatically for you, so they're part of that stack, and this is what you're seeing here. On the right-hand side over here, you're seeing that I'm doing a continuous ping to every single VM and component within the infrastructure to show you what will happen once I kill them, once I delete them from the environment. So I'm basically showing you that. Then on the Cohesity side, I'm showing you how I configure the environment to protect it so that I can do what I'm going to show you here in a minute. So basically, in 2 simple jobs, you create 2 policies. The policies actually contain and have the number of VMs that you're protecting, the jobs, when to protect those jobs, how often to do it. And you'll see that, in terms of the time that it takes. We do that for what I call the authentication stack, which covers vCenters and all the PSEs, and then obviously the rest of the components. These VMs are hundreds of gigs. They're not small VMs. One of them, a couple of them in particular, can actually grow to be terabytes of capacity because they're pulling all the VMware patches so that can actually patch the Cloud Foundation environment. Those are all of the VMs that are part of that particular stack, right? So we're not talking about application specific, in some other cases, which we can, but this is aimed specifically at the infrastructure, right? It can be done on on-prem and also off-site. I'm showing you here also a number of IPs that are utilized by the different nodes that I'm running. So if you look at the screen and you can see it, there's a ping route there that points out 4 different Cohesity nodes. So what I'm going to do is to prove to you and show you the effectiveness of strict consistency in play, because this could happen to you at any point in time. And what I'm going to do is that I'm going to fail one of those nodes in the process of restoring the entire stack. And in a lot of cases, very few products are actually able to do that. So here I'm showing you, I'm connecting to one particular vCenter, to one particular ESXi host, because I can interact with ESXi hosts directly and also the vCenter servers. I'm showing you an API trace, a command that I'm going to do. So instead of doing the 2 clicks to recover the environment, I want to showcase the flexibility and the value of having accessible APIs to do this entire thing orchestrated with one function. So here you see at the top that I have all the different components that are there. vCenter, NSX, vRealize operations, Log Insight, you name it. Everything that pertains to the entire software-defined data center stack here in particular, right? And what I'm going to do is that I'm basically in the background, I'm going to delete every one of them. I'm not going to shut them down and just leave them there. I'm going to actually delete them from the storage component that's there and then reinstantiate them back as part of the process, and you'll see it here. So let me speed up through some of this thing here so then we don't have that much time. And what you're starting to see here, for example, you see that the VMs are turning off, but they're being deleted. So they're all running on vSAN, and I'm actually deleting them completely. And you can see that they're being deleted by the fact that I can no longer ping the VMs, right? This is to show that obviously the infrastructure is alive and running. So as part of that process, what I'm going to do here is, once they're all gone and deleted, I'm going to walk through sort of the Cohesity UI there to show you that, number one, is a distributed control plane. The one that I showed you that I connected there is the one that I'm going to fail. So if I fail the management stack even there, what's going to happen to my environment? So here what I'm going to do is that I'm going to run the API call to sort of reinstantiate the entire environment. And you can see that happening right now. So while that's running, you can take a look at how quick, at the very top, there's a clock that started taking and running once I started a sort of process to show you that I can do all of this in less than 20 minutes. And what's happening here is that you see very quickly that in terms of virtual machines, they'll be able to come back very quickly. And the reason that they come up very quickly is because of what I showed you before. We have the ability to bring back these virtual machines, instantiate them from scratch, right? They were completely deleted. They're not there, but they're running on my storage platform, consuming compute resources from vSphere, and then they're going to be storage vMotion over automatically as part of that process. Now, you'll see how within seconds, there'll be vCenter server coming back, but that's just the actual VM itself. Application specific may take a little longer. In the current release, when we ran this was vSphere, vCenter, I think it was the 6.0, something, whatever release, which took about 11 to 12 minutes for vCenter service to come back up. Now vCenter service comes up in 30 seconds. Imagine how much faster this will be when I do that. So one of the things you'll see in here is that I'm actually running that, and the process is running. So I'll speed up some of the things that I'm going to do here, but keep your eye on the top of the clock. That's the clock that doesn't let me lie in terms of the time that's being used to do this. So as I speed some of this thing up, you'll start seeing that now that the VMs were back, and if you look at in terms of seconds and minutes, right now the PSEs are up, vCenter is up, so everything's back and running in just only 7 minutes, right? You can't even do this as an exercise typically almost any time. So here I'm actually speeding up the process just to kind of get through the time there. And you'll see that all the virtual machines will come up. The entire stack comes up. But then before it comes up, here's where I introduce the big failure. So I'm recovering from a failure. Things are running off my platform. now I'm going to fail one of my nodes in the process of this happening, right? And the way I do that, I go to the ILO and just basically turn it off. Just root, pull the plug, whichever one I want to call it. But essentially, you'll see once it's off, because one of my, you see that the 4 green Cohesity nodes are all green. Once I pull the plug, you'll see one of them goes in red, right? And the one that I pulled off was the one where I was doing all the management I was showing you immediately here. And it should go right about here. So let me just kind of move it. And you see it there, right? Cohesity node is red. So imagine doing that in the real environment. That could happen. That's something that the devices that we have are meant to fail. They're not meant to always run and work. Imagine you use this, you have a solution, which is your insurance policy, but your insurance policy now has a hole, has a single point of failure, because if this were to happen somewhere else, this obviously wouldn't work, right? It will have a problem because it will fail at that particular time. You notice that here, vCenter is back up. I'm able to log in. There are other components, part of the stack, when you use VMware Cloud Foundation, that require a specific management stack to work for them, right? But essentially, all of the components are running, and the fact that you see those red marks there, if you knew about vSAN and how things works, there's a policy attached to those virtual machines, and because it's not running on vSAN yet, it's not compliant, and vSphere tells you. So being able to bring back the entire infrastructure, this happened in basically 26, and then to be fully completed, it'll be in 40 minutes. But it's 40 minutes because I introduced a failure that was not expected within the system to identify and also showcase the implementation of strict consistency in the environment, right? So once you're able to look at the infrastructure in that way, it's very, very compelling, right? These are some of the things that technically may seem very appealing in terms of what you see in the clicks that are going on there. But when you think about the impact this has in an environment for an organization in the enterprise, it translates to financial gains, right? When have you ever been able to really perform DR or data business continuity in this type of fashion at the fraction of a cost with the least amount of risk that are imposed to the environment by the implementation of new technology in terms of software, new capabilities, and some of the things that are now becoming available in the space of data management, right, and mobility and all those things around. So this speaks really high volumes, some things that we weren't able to do in the past. I said it before and I still say it now, you cannot do this in today's world without some of these new technologies, right? And I hope that everyone got a sort of a good thing, and these are some of the things that we'll probably have in the future, and actually these are the things we have actually available today, which I won't be able to show you, but being able to do the same thing for your applications, cross-site data centers, connect them, and be able to recover it within minutes, right? If the infrastructure took under 20 minutes to recover the entire management stack that controls your environment, it'll take you a lot less to bring back your applications, right? And that's some of the things that you'll be able to take advantage and utilize whenever it comes to utilizing Cohesity. And I think that's it for me.